Mind-blowing eye, and it really think like humans. Science fiction and reality don't appear to agree on how we should approach artificial intelligence. While corporations now employ artificial intelligence for more routine activities like driving your car or filling out forms with robotic process automation, science fiction aims to portray artificial intelligence agents as thinking machines. In the current state of artificial intelligence technology, when we engage with these interfaces, we tend to regard them more like vending machines than like human beings. Why? Because anthropomorphizing AI to think of it as a person immediately leads to disillusionment. Because the capabilities of AI today are so limited, stepping outside of the perceived boundaries of what these systems can and cannot accomplish may result in clutch answers like, "I don't understand that," or "I can't do that yet." Despite its extraordinary coolness, the technology just does not think in the same way that you or I do. Let's investigate the various types of thinking that occur within AI systems and how that thinking process functions. Let me first try to persuade you that thinking is a real process. Setting aside the whole debate concerning consciousness, there is a compelling philosophical case to be made for the idea that thought is nothing more than mental computation. As it happens, research has been done on this, and the results go beyond simply conjecturing about what thinking may entail. Nobel laureate Daniel Kahneman describes the two thinking systems in our brains in his book, Thinking Fast and Slow. System 1, which is a quick, automated thinking system, and System 2, which is a slower, more deliberate thinking system. These two types of thinking processes are ingrained in our heads, interacting with each other to shape our perception of the world, much like when our left and right brains are stuck together in one head. Therefore, thinking is more about a few different approaches to decision-making than it is about being correct. Artificial intelligence AI systems of today are trained to think quickly and automatically, similar to System 1, but as a science, AI still lacks a firm understanding of the slow, methodical thinking that comes from System 2. Modern AI systems also commit the same kind of errors as System 1, with prejudices, heuristics, and generalizations being ingrained in the thinking machine during the learning process. There is no deliberate, methodical thought process occurring with today's AI. For instance, how can artificial intelligence AI think when a key element of what thinking entails isn't ready for prime time? With a clearer definition of thinking now in place, what steps can we take to develop artificial intelligence that is more akin to humans? Perhaps expressing feedback loops will lead to something akin to System 2's thinking machine. It appears that we still haven't figured that out. Artificial intelligence models lack a common understanding of the world. As an illustration, I remember Jan LeCun, the founding father of modern artificial intelligence, stating that current AI models are unable to interpret the line he walked through the door. There's a ridiculous reading where we deduce that someone went Superman and smashed through a door, taking it all apart. Another interpretation has the door open or the person walking through the entryway having opened the door. Unfortunately, you are unable to determine which scenario is more plausible in the absence of common knowledge. This demonstrates that even in thinking fast scenarios, our current set of tools can lead to unfavorable outcomes. AI that thinks quickly is commonplace in our environment, and models are gradually trained using enormous volumes of data. The inaccessibility of Google's search algorithms is not the reason you can't create a superior search engine. Instead, is the fact that they possess information that you do not, such as superior web crawlers and cameras on passing vehicles in your neighborhood. At the moment, data holds the most value in AI, and the algorithms are primarily open source and free. It's not always sufficient to collect vast amounts of data to make sure a feature functions. Large-scale human labor is frequently needed, while self-learning algorithms may eventually account for the majority of an AI system's value. For the time being, data is still necessary for the creation of AI systems, and data is the most valuable component of the project. Though it is difficult to divorce thinking from the human state, people are far from ideal. Although we may have average intelligence, we are not meant to handle statistics. Although there's some evidence to support the wisdom of crowds, you could think differently if you see a crowd with pitchforks and torches. It turns out that rather than evolving to become the greatest calculus students, humans have evolved over generations to avoid becoming food for lions. Humans are also hardwired with a lot of prejudices and shortcuts. It is thoroughly recorded. In contrast to causality, for instance, correlation is frequently confused with it. A humorous anecdote from a colleague's undergraduate math degree at a reputable university involves students playing a game called Stats Chicken, in which they postpone taking their statistics course until their fourth year in the hopes that the course will no longer be required. Because human thought is limited in so many ways, we frequently find ourselves perplexed by the conclusions made by our machine equivalents. We think in various ways about one another. We are impressed by this incredible suggestion magic trick when we see a related movie or product recommendation, but we are not allowed to witness the magic trick's execution. Because machine-based thinking is founded on so much truth and mathematics, One is inclined to believe that it is superior to or cleaner than our messy organic process. That is accurate in a lot of cases, but it also conceals a sinister secret. Many times, the reasons behind artificial intelligence's superior performance are unclear. We are experimenting with instruments that we don't fully understand because engineering has gotten a bit ahead of science. We can test them and we know they function, but we lack a strong mechanism to demonstrate the reasons behind their effectiveness. Even in reputable academic circles, there are some claims. See slide 24. Here, the fundamental idea underlying artificial intelligence as a scientific discipline is not yet well defined. The engineers are the target of more than simply mathematicians' jealousy and slander. AI is an assemblage of disconnected fields, and there is no correlation in the field between explaining why something works and figuring out how to make it work. Therefore, the query concerning AI and thought is a knowledge query as well. If you don't understand the inner workings of an automobile, you can still operate one, so perhaps you can think even if you don't understand how it works. How can engineers accomplish anything in the field of artificial intelligence if there isn't a solid theory behind it? As for testing and training AI models, there are effective methods that are sufficient for the modern economy. Artificial intelligence comes in a variety of forms such as reinforcement learning, unsupervised learning, and more. Instead of asking questions like, "Is it thinking?" or "What is the test score?" engineers typically ask queries like, "Is it broken?" A prominent form of artificial intelligence that quickly produces predictions in a certain domain is supervised learning. For supervised learning on big datasets, feed-forward deep neural networks are the state-of-the-art apparatus. This kind of mechanism isn't truly thinking. Rather, it is trained to select a label for classification or a regression coefficient for regression from a set of observations. Without a robust validation phase, the way judgments are hard-coded into neural networks during learning is not readily apparent. For a long time, for instance, more transparent AI models have been available in fields like game theory for military strategy. An interpretable AI system is often developed using explicit models, such as decision trees, where a set of rules is learned that defines your path from observation to prediction, akin to a choose-your-own-adventure book where each piece of data follows a path from the start to the finish. In summary, artificial intelligence has come a long way in imitating some features of human thought, but is still a long way from reaching real human-like cognition. While modern AI is superior at making decisions quickly and automatically, much like our brain's System 1, it is deficient in deeper, more thoughtful System 2 thinking. The shortcomings of AI are made clear by the lack of feedback loops, common knowledge, and sincere comprehension. Though we still don't fully comprehend the algorithms and large datasets that power this technology is nonetheless astounding. It is still unclear whether AI will ever be able to think like humans or if it will only be able to mimic human thought processes with cleverness. Enjoyed the video? Don't forget to like, subscribe, and leave a comment below. Your support means a lot and helps us bring you more great content. Thanks for watching.